Hello everyone, this is our last video in the 5-part series of using the smart home sensors and outputs with the microbit. And this one is a pretty simple one, but it's pretty cool because you get to use a pump, and a pump can move water, can move liquids. So we're going to use some electronics to move some liquids in this example, and we're going to move some water from one cup to another based on if a sensor detects a water level change. Okay, so you could use this for like automatic plants. You could use this for an application like a sump pump down in your basement in case you want to sort of have a safety net for flooding issues. There's a few different uses for this kind of technology. So this one's nice and simple. I really like this one because it's an analog system. So the water level detector, when it comes to the sensors and outputs, there's not a lot going on. We just turn things on and off. So the start doesn't need to do anything. Our start function can be completely blank. Okay, we don't have to initialize anything or set up LEDs or set some variables. We can just leave it blank. Okay, so that's nice. So I'm going to move on to the forever loop and see what's in here. So the soil moisture sensor is a two-prong sensor, and it's analog. So it has a voltage difference across its pins. And if the voltage passes through, we're going to get a positive value or a negative value, and it's analog. So it's not going to be a true on-off. It's going to be a range. Okay? So we're going to have to adapt for that range. And that's going to come in as an analog value on pin 1. The question we're going to ask is, has water been detected by that sensor? If the soil sensor has a value that comes back greater than 500, we're going to say yes, water has been detected. And if the soil sensor comes back as less than 500, we're going to say no, water has been detected, and we're going to assume our environment is dry. Okay. So in this case, we're going to do a water level detector that detects water, and if it does, it turns the pump on to move the water away. So this is more of a sump pump, like in a basement idea. If you wanted to do this for automatically watering plants, you just flip the logic. Okay, so when something's dry, that's when you'd move the water to water the plant. Okay, so again, we're going to base this project on a pump in the basement pumping water out. So yes, let's say water has been detected. What does this look like? Well, let's sound the buzzer. That'll be an audible output so that we can be notified as the user. And then we're going to turn on a thing called a relay on output pin 2. I have a little note here. In this case, the relay is a switch. We can send a signal to it digitally, and it can control whether something has power or not. And in this case, it's going to control the power of the submersible pump, which it's hooked up to. Okay, so we can use a relay to turn things on and off, like pumps or lights or fans, larger pieces of equipment that don't necessarily have onboard electronics, but we can use these kind of controls and these kind of features to control larger furniture using our microelectronics, our microcontrollers. Okay, so that was just a little note. Then we're going to wait 10 seconds and then return. Then we're going to come back up and ask the question again. So ideally, this would keep asking the question, has water been detected? And every time it comes back, yes, it'll pump for 10 seconds. Then it'll go back and ask the question again until the water sensor comes back as a no. When it comes back as a no, so it no longer detects water at a level of 500 or greater. Um, and again, remember 500 seems kind of weird, but this is an analog signal. Okay, so it's sort of think like a nice like graph or something that has like a peak and a slope. And when it goes less than 500, we're going to turn the relay off, and that'll turn the pump off. Okay, so up until now, we've been dealing with digital signals, digital inputs and outputs, using control logic that way. This is our first time using an analog signal, and as such, you'll notice that it just has like a value of 500. We sort of saw this a little bit with the light intensity sensor at the start of this series. Again, I was just saying like, I think it was 50 intensity. Again, an analog value. Okay, so not a true yes or no, but a range. Okay, all the pieces in between. So hopefully this activity is fun to do. It'll be really fun to see the water moving. It's a nice quick one to code. You can see the logic, the computational thinking behind it, that we need to sort of adapt into our code is not a lot. It's pretty quick. And when you actually code this one, it'll be really quick. Have fun. This is the last of our 5-part series. And if you get through all of these, I will be pointing you in the direction of additional projects that you can build. Thanks. Bye.